SwayamPrabha. Digital India. Educated India.
We are going to start talking about some of the kinds of jet engines which had actually appeared more than 60 years back in world of jet aircraft. However, for various reasons they were kind of superseded by the gas turbine based jet engines, which we have been talking about over this lecture series. However, it is probably right that we should have a look at some of those jet engines, which were indeed jet engines, and they actually flew along the same time when the gas turbine based jet engines first flew, and they were kind of disfavored by various reasons for various manufacturers and aircraft builders. However, they are coming back. They have reason to have their own applications where they could be useful even today, and we should have a look at some of them, how they function and how they can be deployed for flying aircraft. In some sense, these were simpler jet engines, and that is indeed one of the reasons why those jet engines appeared before the gas turbine based jet engines, because the gas turbine based jet engines, as we have seen over this lecture series, are indeed rather complex machines. They do have all kinds of complex parts like compressors and turbines, which make the engine extremely heavy, bulky, and of course, very complex to both design and analyze and finally control during flight. Much simpler versions of jet engines appeared alongside after the World War II, immediately or around the time of World War II, by various manufacturers, essentially to begin with for the purpose of the war itself, and later on they were flown by various people. And as I mentioned, they were not favored in comparison to the gas turbine based jet engines, and hence they were not used for regular flights, either for military or for transport aircraft purposes. However, they are indeed being looked into again for various kinds of aircraft applications by various manufacturers, both in Europe as well as in USA. Now, these engines, which go by the name of Pulsejets, Ramjets, and version of Ramjet, which is known as Scramjets, are very simple engines, and we will have a look at these engines over the next 2-3 lectures, and we will take a good look at them, and we will find that they actually do have application potential under certain circumstances in certain kinds of aircraft, and those kinds of aircraft actually are looking into these engines, the modern versions of them, the improved versions of them, and how they can be deployed for certain aircraft flights. So, this is what we will be doing over the next few lectures, looking at Ramjets, Pulsejets and Scramjets, how they function, what kind of aircraft they are used, they have been used in the past, and what kind of aircraft they are likely to be used in future. We will look at how they operate. We will look at what kind of thermodynamic cycle they actually are used for, and finally, we also look at their performance and some aspects of how they are designed over a period of next 3 or 4 lectures. So, let us take a look at these jet engines, which are Pulsejets, Ramjets and Scramjets. Some of these engines, which have been, as I mentioned, around for more than 50-60 years, were developed essentially for the purpose of military purposes. Now, of course, many of the aircraft and many of the engines were indeed developed for military applications to begin with, and even today many of the new technologies are often used first in military aircraft, which are indeed the more demanding kind of aircraft and hence require more demanding and more challenging kind of engines to be designed and built. So, during World War II, certain kinds of ramjets and pulsejets were used during the war as war material, also because, as I mentioned, they are very simple kind of jet engines. And at that point of time, it was a bit of surprise to the other party, and in a sense they must be considered as successful deployment of jet engines. Also, one must remember at that point of time, the gas turbine based jet engines which we have been talking about had not been developed so much, and as a result of which these pulsejets and ramjets were considered to be reasonably competitive to the gas turbine based jet engines or the turbojet engines as we call them. So, let us take a look at what these ramjets and pulsejets are all about and exactly how do they function. To begin with, all heat engines and all jet engines have to have some kind of a thermodynamic basis insofar as they are all heat engines. Now, these ramjets operate on the same cycle as turbojet engines, and we shall be looking at this thermodynamic cycle probably in the next lecture. Now, the name ramjet engine is given with a purpose. The purpose is that the word ram essentially refers to the fact that certain amount of air compression by the ram effect is being used here, and hence the entire compression that is needed prior to the combustion is effectively done by the ram effect, which we have studied in the course of our turbojet engine series, lecture series. So, the entire compression is done by the ram effect, and it occurs in the intake of the engine, and it produces significant rise in static pressure sufficient to allow the flow to go into the combustion chamber. Now, as we know, in jet engines we need to burn the fuel preferably in a high pressure, and higher the pressure at which the fuel is burned, faster is going to be the burning process, more efficient is the burning process, and hence this high pressure is created, and then the fuel is injected into the air stream and allowed to go through the combustion process, during which of course heat is added to the working medium, which is again air. And then this mixture of burned fuel and air is essentially a gas. Now, this mixture of burned fuel and air, which is then expanded through a nozzle system to the atmospheric air, which is under atmospheric conditions, and this expansion of course creates the jet which helps us produce the final thrust. So, this is in a simple way how the ramjet is expected to create thrust for flying of aircraft. If you look at a very simple diagram of a ramjet, what it consists of is a flow coming into the engine, and what we see here is that the expected flow is a supersonic flow. We shall see as we go along, and it's probably appropriate to state that a ramjet would be more useful under supersonic flight conditions, and as a result of which what we have shown here, that the flow is coming in with supersonic flow. However, the flow needs to be decelerated or diffused substantially to a subsonic flow to affect the combustion process, and this combustion process is as we all know is essentially done with the help of certain flame holders, which are shown over here. This arrow shows a number of flame holders, and then the combustion is kind of held here in this zone under subsonic flow conditions, and then the hot gas is fed into the nozzle, which is often a convergent divergent nozzle, and then the hot jet goes out to create a jet thrust. So, this is in simple how the ramjet indeed operates. There are various facets by which the ramjet operation can be looked at. So, let us look at some of those various points which make the ramjet engine indeed operate. Ramjet engine, like any other jet engine, essentially produces power or thrust by increasing the momentum of the working fluid, essentially by induction of energy by combustion of fuel, so that the momentum of the exhaust jet substantially exceeds that of the incoming air, and this needs to be done on a continuous basis, because for flying of an aircraft you need to produce thrust on a continuous basis. Now, in contrast to the other kinds of air breathing engines that we have studied earlier, the working cycle or the working of the engine is accomplished without additional components of compression or expansion, and that means there is no need for a compressor or a turbine in this kind of jet engine, and it also does not require a kind of enclosed combustion, which we have seen in turbojet engines, where you have can type or cannular type of combustion. Now, that kind of combustion is not required. This combustion is entirely through the entire duct through which the flow is flowing. So, it's not even annular, it is a full duct combustion process, and this allows the combustion process to be carried out over the entire duct of the ramjet engine. So, the entire process of compression, expansion and combustion in ramjet engines are quite different from the other kind of turbojet or turbofan engines that we have done earlier. There is no compressor here, there is no turbine here, and the combustion process is done over the entire duct. So, it is neither cannular nor annular, and the entire duct chamber is essentially used for combustion, and thereafter as essentially a jet pipe before the entire flow is released to the nozzle. So, the ramjet engine essentially gets rid of compressor, turbine and all kinds of heavy combustion systems, and hence one can say that ramjet engine is mechanically the least complicated air breathing engine for thrust production for flying of vehicles. Now, for aircraft thrust production, we have gone through various versions of turbojet engine and turbofan engine. The ramjet engine, which is also a jet engine, is easily the least complicated of all kinds of air breathing engine. Remember, it is still an air breathing engine, it is still using air as a working medium, and hence it fundamentally still remains an air breathing jet engine for thrust production. The high pressure gas, which has been created through the combustion process, the pressurization was done by the intake process, and the combustion created the gas. Now, this high pressure, high temperature gas is now expanded through a nozzle, which essentially converts a low subsonic flow in the combustion chamber or coming from the combustion chamber into a supersonic jet. The minimum jet speed at which it goes out is sonic, and most likely it is going to be supersonic. And then this mixture of air and burned fuel, that is the gas, is normally exhausted through a convergent divergent nozzle, CD nozzle. You have studied various kinds of nozzles in the nozzle chapter, and the CD nozzle, as you remember, is one of the kinds of nozzle which allows the flow to be converted from subsonic to clear supersonic flow. So, that is the kind of nozzle that is normally used in ramjet engines. The exit pressure at the exit face of the nozzle is likely to be of the same order as the ambient pressure or the atmospheric pressure, and which means that somewhere in the nozzle, in the CD nozzle, the flow will be reached, which is ideally likely to be in the throat area, and the choking pressure wherever it is reached, the sonic condition is reached, is somewhere near the throat, as I mentioned, is likely to be higher than the atmospheric pressure. So, the choking pressure is quite often higher than the atmospheric pressure. However, at low supersonic flights, if the ramjet is being used for low supersonic flights, the exhaust may be sonic, which means just sonic, through a simple convergent nozzle, which is the simplest kind of ramjet engine one can think of, using just a convergent nozzle. However, at Mach number, very high Mach numbers, at Mach number 5 and above, the unit becomes essentially what is now known as supersonic combustion ramjet or scramjet, in which the combustion itself has to be carried out in supersonic flow. That means, the flow in the combustion area deep inside the engine is still supersonic, and the flow has not become sonic anywhere inside the jet engine. And now, that kind of engine is essentially referred to as scramjet engine, and we will be studying scramjet engine in the course of this lectures. Let us take a look at what are the certain advantages of typical ramjet or for that matter scramjet engines for use on various kinds of aircraft. Now, as we see here, as we increase the Mach number of the flying aircraft, the typical specific thrust that is created by various kinds of jet engines essentially show a characteristic. These characteristics are shown here with reference to two different kinds of fuel. One is the normal hydrocarbon fuel that is used in all kinds of turbojet engines, and the other is the hydrogen fuel, which often uses hydrogen and liquid hydrogen and probably or preferably liquid oxygen. So, let us take a look at these two kinds of fuels. In case of aircraft usage, the hydrogen, liquid hydrogen will be used along with air, which will essentially be the oxidizing element. So, if we use a hydrocarbon fuel, the blue line here or the blue zone here shows that various kinds of turbojet engines, once their Mach number, the flight Mach number increases at flight Mach number of the order of 2.5 to 3, slowly their specific thrust creating capability goes down, and somewhere over there the ramjets essentially become more and more useful. The turbojet thrust creating capability is going down, and the ramjet thrust creating capability is somewhat higher in the range of Mach number, say from 3 to 5 or 6. Above Mach number of 5 or 6, quite often you would find scramjets essentially are more useful, as the thrust creating capability of the ramjets are even lower at that kind of very high flight Mach number, and they start dipping below the scramjets, and scramjets become the better thrust creating engines at that kind of flight Mach number. Of course, as we know, if you go to flight Mach number of 10 or above, you would probably need to use rockets to create sufficient or good thrust for flying of vehicles. On the other hand, if you use a different kind of fuel, that is hydrogen fuel, liquid hydrogen, using air as the oxidizing element and still air as the working medium, what we see here that essentially they do create more thrust, but as we know, the turbojet engines normally have not been using hydrogen as a fuel, because hydrogen is essentially a very light element, and hence to carry it around you need a lot of space, a lot of volume in an aircraft. So, typically most of the aircraft as of today do not use hydrogen fuel as of now for creation of thrust, even though as we can see here their specific thrust creating capability is indeed much higher. Again, at higher Mach number, at around Mach 3 or above, the ramjets essentially start showing better thrust creating capability than the turbojets, which are now going down, and the ramjets hold forth from about Mach 3 to Mach 5, during which its thrust creating capability is the best amongst all kinds of jet engines. Above Mach 5 or 6, the scramjets essentially become the most efficient thrust creating engine, and it can hold forth for creating thrust up to almost Mach 20. So, if one is using a hydrogen fuel and one uses scramjet engine, that kind of an engine with hydrogen fuel would be very good thrust creating engine or a power plant for flight of vehicles up to Mach 20 or so, and that is where many of the applications are being used today for scramjet engines. That new aircraft which are coming up, which are called hypersonic aircraft, these are the aircraft where scramjets engines are being deployed as thrust creating engines. So, as we see here, depending on what kind of engine you have, what kind of aircraft you would like to make use of, on which you like to put the power plant, and at what flight Mach number they would be flying for most of the cruise. These are the considerations which decide what kind of engine you are going to use, whether you are going to use a turbojet engine, whether you are going to use a ramjet engine, or whether you would like to go for a scramjet engine. Also, as we can see here, the hydrogen, which is a light element, actually indeed creates higher specific thrust, that is thrust per unit mass flow, and as a result of which they indeed are better fuels. So far for various aircraft applications, they have not been used so far, as I mentioned, because they are very light and you need a lot of fuel tank space to carry them around. However, for ramjets and scramjets, which are for small duration flights, hydrogen fuels are very competitive, and it is quite possible that hydrogen fuels will be used. But as of now, the experimental and other aircraft which are being flown with ramjets and scramjets are still using the hydrocarbon fuels, and one of the reasons is the chemical kinetics of hydrocarbon fuel is very well established over more than last 50 years, whereas the hydrogen fuel, even though it is a cleaner fuel, its chemical kinetics is still in the process of getting established, apart from the fact that it is a very light fuel. Let us take a look at a color picture of what a ramjet would look like during its operation. It would typically have flow coming through the intake system, which would typically have a spike like this, a central bullet, which will negotiate with the incoming flow, which is likely to be supersonic, and then it undergoes supersonic diffusion and then subsonic diffusion, and at the end of the diffusion process, then we have the burner, and through the burner the flow then is released through the nozzle in hot gases for creation of thrust. So, this is another very simple with a little color explanation of what is likely to be happening in a typical ramjet engine. Let us take a diagrammatic schematic look at what is happening. As I mentioned, the flow comes through the intake system, and the intake system would have a central bullet like this, which is placed there essentially to negotiate the supersonic flow that is coming in. Now, as you well know, the supersonic flow, the moment it hits a solid body, and in this case the solid body has to have a very sharp cone over here, a sharp nose, which immediately creates a shock system. Now, this shock system is what is known as the intake shock system, and these part of them are the internal shocks, and it is possible that one of them would be anchored between the nose cone and the lip of the engine, and the flow comes through these shocks, and in the process of flowing through the shocks, the flow get diffused, and finally, through one normal shock, the flow finally becomes a subsonic flow. And then the rest of the diffuser essentially is a subsonic diffusion process before it comes into the combustion zone, where, as you can see, the flame holders are placed there, and the flame holding process is similar to what we have done in the combustion chapter earlier, that the flame needs to be stabilized and essentially to be held, so to say, in one place, anchored in this place, so that the combustion process is done under a controlled situation. And once this combustion is completed, the hot gas is then released to this nozzle, which, as I mentioned, now has sufficient pressure through this compression or ram compression process. It has developed sufficient pressure, and it has now been infused with sufficient amount of combustion or heat release, so that at the face of the nozzle, intake face of the nozzle, it has very high pressure and very high temperature. And with this high temperature and pressure, when it is released through the nozzle, it produces high velocity jet. So, the expansion and exhaust is normally through a CD nozzle, and as we have done before, to have a CD nozzle, you must have sufficient pressure and temperature to begin with to make full use of a CD nozzle. So, this is how a ramjet engine actually operates. It has various components, the intake, which needs to be designed very accurately for the particular flight Mach number at which it is likely to be flown, at which the aircraft is likely to be deployed, and this would indeed decide the shape and size of this central bullet cone, and the angle at which this nose cone is to be created will decide, of course, the shock that is created, and those shocks will decide essentially the rate of supersonic diffusion that takes place, and of course, the final aerodynamic efficiency of this intake system. If the supersonic flow and the nose cone geometry are not in consonance with each other, if they are not matched to each other, the shock system that will be created will be highly loss making shock system, and as a result the intake efficiency will be very low, and that will of course indeed tell on the overall jet engine efficiency, the ramjet engine efficiency, and the efficiency would be lower. So, we need to create an intake system which is uniquely designed for that particular flight Mach number at which this ramjet engine is likely to be flown with the aircraft. This is the German V2 bomber, in which ramjet engine was utilized, and as you can see here, it is a very simple aircraft in which the flow came in right from the nose, and indeed this was not a supersonic aircraft, it was actually a subsonic aircraft. A more modern ramjet powered supersonic aircraft, which is being designed, shows that you do have this nose cone at the front, a sharp nose cone which essentially negotiates the supersonic flow. The shape of the aircraft tells you that it is a blended body wing body aircraft, which is typically designed for high Mach number. That means, the Mach number of this aircraft is likely to be above Mach 3, and hence the shape of the aircraft is typically a blended body shape, and the ramjets which are being shown here sort of corresponds to the kind of ramjet that we have been discussing. And at the back over here, there is a weapon that has been deployed over here. So, this is the kind of ramjet powered supersonic aircraft that people are thinking of, where it will be flying somewhere around Mach 3 or Mach 4 over a certain distance, and is most likely to be for military applications. Let us take a look at what kind of pulse jet engines which people have used before, and how do they function. Now, pulse jets in a sense are similar to ramjet engine in simplicity, in the sense there is again no compressor, there is no turbine, and there is no enclosed combustion chamber. Again, we have an open combustion chamber, and this kind of engine was used again by the Germans during World War in a V2 V1 aircraft, which used the pulse jet. You can see here the pulse jet engine is mounted over here, and it uses compressed air source for initiating the engine, which we will discuss in a few minutes. And this is the shape of the German V1. So, this is also has been used during the World War by the Germans, and we shall see later on what kind of use they are likely to be if they are to be used in modern aircraft. Let us take a look at how the pulse jet engines indeed operate. As I mentioned, it is again a very simple kind of a jet engine, insofar as it is still a jet engine, and it is using air as working medium. So, the air comes in from the front, and it goes through a set of valves through which the air is allowed to come in intermittently, not on a continuous basis. So, as the name suggests, it operates in pulses, and the thrust is created in pulses. So, the air is allowed to come into the jet engine intermittently, and once it has been allowed to enter, soon thereafter there is a chamber over here at which the air is at a very low velocity or more or less still, and when this valve closes, this chamber essentially has more or less still air in which the fuel is burned, and the combustion takes place. So, this is the combustion chamber in which the combustion takes place more or less in still air, and then this combusted gas is released through the long tailpipe and then released through a nozzle. There is indeed going to be a nozzle system over here for creating the jet. So, the pulse jet engine operates under situations where the flow is allowed in intermittently at pulses, and as we shall see as we go along, that in the early days the pulses used to be of the order of 50 pulses per second. The modern pulse jet engines have been going much higher than that, of the order of few hundred pulses are possible. There are mechanical limitations of creation of the pulses, and this mechanical limitation of the pulses essentially is being pushed to higher limits over the modern pulse jet engine development. So, some of these developments are being done in the modern era to bring the pulse jet engine to the modern aircraft flying experience, and as I mentioned, the pulse jet was indeed used 60 years back during the World War. So, these are the various kinds of development that are taking place. Let us take a look at how these pulse jet engines actually function. The air is drawn into a system through which the through a set of valves, as I mentioned, and these valves operate intermittently, and then fuel is sprayed into the combustion chamber. Now, the fuel spray we have done in the combustion chapter, it tells you very clearly that the fuel spray has to be atomized, they have to be evaporated, they have to be mixed. So, all that phenomena of combustion that we have studied in the combustion chamber chapter are indeed valid also for ramjets and pulse jet. So, the combustion would have to be carried out more or less the same way that we have done in the combustion chamber combustion chapter earlier. So, once the combustion occurs, it is an enclosed chamber now, unlike even ramjet. So, in that enclosed chamber, once the combustion occurs, the pressure builds up. Now, normal thermodynamics will tell you that once you have increase of temperature in an enclosed space, any volume of air or gas will also undergo change of or increase of pressure. In a flowing fluid, in a ramjet or in turbojet engines, that does not happen, because it is a continuously flowing fluid. But in a pulse jet engine, what has been done is something very similar to that is done in piston engine, that the air is captured in a volume and in this volume the fuel is sprayed, and the fuel spray is allowed to burn and the combustion takes place, and in the process not only the temperature, but the pressure also goes up. So, the process of increase of temperature and pressure now occur in a enclosed volume, and essentially it is more or less like a mini explosion, and during this process, as I mentioned, the pressure goes to very high values. Now, this high pressure, high temperature gas can be released through the jet pipe and through the nozzle to create your thrust. So, one can see here that slight details of the operation of the pulse jet are different from that of the ramjet. Now, one of the major difference that comes out is that for creation of thrust, you are not using flowing fluid, which means that a pulse jet engine can help an aircraft to take off from ground, which a ramjet engine cannot. A ramjet engine works on ram effect. Now,